Hi, everyone. So, here is the plan for today. Seniors, if you have your study guide and you're finished, I will take it.
Wait, can I do it tomorrow?
I did it!
You can give it to me tomorrow. That is fine.
Do we even have that yet?
Okay,
Yes, Lily!
Lily!
Thank you. All right. Shh.
Are the other seniors, are they marked as like absent in the...
I have yet to get to the attendance. I'll be with you in a moment, though. All right. Shh. Please stop talking.
There they are.
Seniors just walking in. If you have your review and you'd like to unload it here today, I will take it from you today. If not, shh, seniors, I need it by 2:45 tomorrow, or you don't get to use it and you miss out on the extra credit. Okay?
Don't rush the house.
So, don't forget. Seniors, what are you going to remember to do tomorrow?
Turn it in by 2:45.
Before 2:45.
Thank you.
What if they turn it in at 2:45? Ooh, I don't know about that.
If my door is locked and I am gone, I ain't taking it.
Oh, shit.
If it's on the ground under my door, you slide it under there and putting it in the garbage.
Guys, I'm nervous.
Yeah, that's right. That's right.
Just do it now.
Seniors, also, the last opportunity for later missing work is 2:45 on Thursday. If I am tomorrow, Thursday, if I have not got an email with properly synced pages before 2:45 on Friday or on Thursday, tomorrow,
Thursday.
I'm not taking it.
So what happened?
If I do not have an email with properly synced pages, I'm not accepting anything else.
Even about us, we juniors. We have to send an email.
Nobody's talking about you.
That is not
All right, hey, zip it. I can't hear myself think, nor can anyone hear what I'm trying to say. And I'm getting the same questions that I've answered multiple times because everybody's talking over me and nobody's listening. So, seniors, 2:45 on Thursday is your last opportunity for later missing assignments.
Yes.
If you have later missings, you need to send an email to let me know to check for it, and the documents have to be properly synced. If you send an email and things aren't properly synced and I can't see it on my end, it's not going in. Okay, so if you have later missings, make sure, triple check that it's synced properly. If you have it in the email sent to me by tomorrow, the start of school, I will try to respond to you if it's not there to give you a second chance at syncing. Okay?
Okay, thank you.
You're welcome. Juniors,
That's not me.
today, we're going to start talking about sequences and series.
We're learning.
Yes.
Loser.
Seniors,
Yeah.
you guys are going to be non-disruptive and finish your study guides if you haven't.
If I finish it, can I take a walk?
No, but you can play on your phone quietly,
Is it?
and I will not hassle you about it.
Happy relationship, I know it.
Yes.
It's extra credit if we turn it on, right?
And you get to use it on the final.
Woo!
Yeah.
Wait, us seniors do that too, right?
When it's your turn, any seniors need an extra copy.
Wait, can I have it?
An extra copy?
Yeah.
Yay!
Grace, you need an extra copy? Adriana. Sure? Maddie? Yeah.
If you don't, then you're done for though.
You're junior.
I'm done so either way.
You don't need it. Yours will be different.
Now look.
Ours will have a little bit more.
You'll have more.
Right. Oh, it is different. Oh.
Okay.
Yeah, you guys like.
Yeah, you were right. But this
That was
first
just
one,
weird.
it was already full.
All right.
You're right.
What? Adriana wants to do a call. Also, guys, I have to. She's like, I want to Wait, so how many like chapters do we have left?
More than you want.
Like,
This is chapter 16.
Wait, actually,
Well,
Mr. Floyd,
yes.
sorry. Because I already finished my study guide, do you think I could go see Miss Pierce really quick? Because I was supposed to have a meeting with her, but she canceled it.
Yes.
definitely not, Hannah.
I'm gonna be back. I'm coming back.
So, chapter C.
Chapter what?
Yup.
Chapter C.
If you want to call it 16, you can call it 16. That's okay.
That follows the pattern. Glad you don't know learn chapter.
We went from like chapter 7 to like chapter 12.
No, you can't leave. Only certain things that I can never last week. Next week,
Yes. Bathroom, yes.
But it's okay, because you can just find a revenue.
I'll probably just put my headphones and then I'll wear my new shoes. What are you guys doing?
Learning.
Okay.
I love to open my mind.
So, today, we're going to do very little, but we're going to do a little. We're going to talk about the definition of a sequence. We're going to do some basic vocabulary and notation involving sequences. And talk about how to write one specific type of sequences that's an arithmetic sequence. Okay? So, a sequence that's just a function. So it's a type of function that goes from the natural numbers. What are the natural numbers again? 0, 1, 2, 3, 4, 5, 6. To the, well, not negatives,
No, that's not an natural.
right? To the real numbers. Okay?
Cash someone got time for
What's the real number? Anything
Anything you can represent with a decimal.
that's not imaginary.
Correct. Gross, you're like on my last note. Can we just can we dial it back? Thank you. Like I understand, I really do. Can we just,
Just come down, please.
We have to chill on them.
Just come down, guys.
thank you. Okay. So, the way we can represent a sequence you can write a sequence like a list. So for example, I might write a sequence such as 2, 4, 6, 8, 10, ... what would we call this sequence? Do you recognize these numbers?
Yeah, even numbers.
The positive even numbers, right? Everybody's okay? So you can write a sequence with something called an explicit formula. So that explicit formula here is A, and then n is the subscript, equals 2n. So we'd say an is the nth term of the sequence, and n is the term number. So if I look at this sequence above, 2 would be the first term, 4 is the second term, 3 is the fourth term, or 6 is the third term, 8 is the fourth term, 5 is the fifth term. Everybody's okay? So if I called this sequence A sub n, 2 would be A1, 4 would be A2, 6 would be A3, 8 would be A4, 10 would be A5, so on and so forth. Is everybody okay with the notation we're using here? So this explicit formula should remind you of something. This looks to me very much like function notation, where my A sub n is just like my f of x, and my n is just like my x, right? So we could use it the same way. If I wanted the 10th term of the sequence, I'm looking for A sub 10. So the 10th term of that sequence would be 20. Does everybody feel okay? Just trying to work on the notation vocabulary a little bit right here. Do we feel okay? So what is the term number for A10? 10. What is the value of the term A10? 20. Okay? The value is what it's equal. The term number is the subscript. Like the term number is what order it appears on the list. What position is it? And the term value is what is the number in that position. So in my list, the 10th number listed should be 20. That's what we're saying. Does everybody feel okay with what these vocab and the symbols and the notation here? Good. A third way we could represent this is with something called a recursive formula. So an example of that recursive formula So this recursive formula is A sub n equals A sub n minus 1 plus A sub n minus 2. We would think about this as the term before, and this one as the term before the term before. So for example, if I want a sub 3, that should be a sub 2 plus a sub 1, which I'm told in my formula is 1 and 1. Is everybody okay? If I want a sub 4, that should be the term before and the term before the term before. A sub 3 we just found, and a sub 2 we're given. If I want a sub 5, that's the term before plus the term before before. So that's 3 plus 2, that's 5. Is everybody okay with how I'm generating the terms of this sequence? Yes, Gabby.
Are a sub 1 and a sub 2 always?
Will they be given to you? Like however many terms you need to write the next term, you have to supply at the start with your recursive formula. Sometimes one term is enough, just the first term would be enough, but this one is based on the previous 2 terms, so I need to give the 2 terms at the start. If I had one that used 3 terms, I'd need to give you 3 terms at the start. Right? I need to preload with however many you need in the formula. Does that make sense? Now, this particular formula has a name, or this particular recursive sequence has a name. It's a famous name. It's called the Fibonacci sequence.
Oh.
Yeah, you've heard of it. The Da
The
Vinci Code? Yes, it does appear in the Da Vinci Code. Terrible book, cool formula.
Why is the book terrible?
It just, I don't know, it's not very good. I didn't think it was very good.
Have you seen the Da Vinci Code?
The movie I've seen also. The movie I think is worse than the book.
Oh, wow. That means
I think it's pretty bad.
harsh credit.
Yeah.
Are you a movie critic?
I have my opinions. No, like the book strains credulity as to like the main character's ability to pick meanings out that I don't really believe that you could do in the
It's unrealistic.
yes. And the ideas are largely like recycled. Like it's a bad Michael Crichton impersonation without the research that like a Michael Crichton book would have. My opinion. All right. Everybody okay with the idea of what a recursive sequence is doing? Yes.
This is not super relevant to the recursive sequence.
That's okay.
Is it the red numbers you've just put in the Fibonacci sequence, or is it the
Yeah.
recursive formula is the Fibonacci?
So the recursive formula is how we generate the terms in the Fibonacci sequence, which is starts 1, 1, 2, 3, 5, 8, so on and so forth.
Okay, thank you.
You're welcome. What's the disadvantage of the recursive sequence over the explicit sequence? What if I want the 1,000th term in the
You have to find
recursive?
all of them.
I need the 999 before it to do that. If I want the 1,000th term in the explicit formula, what do? Just plug that in for n and I'm done, right? Everybody's okay? What's the advantage the recursive formula has over the explicit then? Seems like the explicit is much more useful.
Why is that?
The advantage is that the equivalent explicit formula can be very difficult to write for something like the Fibonacci sequence. Because here's the thing that's going to blow your mind. If you look at the explicit formula for the Fibonacci sequence, it contains irrational numbers. Which is like, but, all the outputs are rational, are like integers. Like who would come up with that? It's a really difficult formula to derive if you've never done it before. I mean, once you know what to do, it's not bad. But like if you've never done this before, would be quite challenging to get to the formula. So that's the main advantage of the recursive. For some sequences, it's massively easier to write a recursive formula than an explicit. The sacrifice you make, though, is that generating terms of of a recursive sequence can be a pain. But a computer is very good at this kind of work, and you just usually assign a computer to do it if you want the 1,000th term. You can do it in Excel in like 2 seconds. You just set it up and then do a drag and spit it out. All right. And the last way you could do this or represent a sequence is with a graph. So again, if I went and graphed that sequence at the beginning, 2, 4, 6, 8, 10, the x-axis is the n, the y-axis is the a sub n. So like, I would have 1, 2, 2, 4, 3, 6, etc., right? Am I going to connect the points?
Yeah.
No. Why not? What is the domain for a sequence?
Positive. Well,
No. It's only the natural numbers. There are no inputs between, say, 1 and 2.
oh, so it'd be really messy.
No, it's just points. It's a discrete graph. It's
Well, if
not
you were-
connected.
If you were to do like the negative infinity positive infinity, it would be like really like messy.
Well, by definition, we're not defining things, right? Because the input, the domain is the term number. You can't have, well, that's number 1.6 in line, right? That's not how you order things. You order them first, second, third, fourth, fifth. There's not like 1.2th, right? It's like we're doing an ordering as the domain. So it doesn't make sense to use like a decimal for an ordinal number. Does that?
Yeah, that makes sense.
Okay. So always points, never connected. So, okay? All right. Today we're going to talk about a special type of sequence. Well, I'm going to define 2 of them today, but we're really going to talk about 1 in detail. We'll save the other one for later. The first one is called an arithmetic sequence. Yes.
So that's like counting by twos.
Hi.
Mhm.
I have to go office and then. Sorry.
Okay.
So, thank you.
You're welcome, Grace. Don't
See
forget
you
to
on
drop
Friday.
off. Yeah, don't forget to drop off your packet
I know,
tomorrow.
I'll bring it tomorrow.
Okay.
Hey.
The exam for seniors is Friday at during second period, 9:15 to 10:35
And where is it?
in the media center, I think.
You have to be there by 9:30?
Uh, Okay. Everybody's, so for example, and as Emma pointed out, if we had the sequence 2, 4, 6, 8, 10, notice that to go from 2 to 4, we added 2. And to go from 4 to 6, we added 2. And 6 to 8, we add 2. And 8 to 10, we add 2. 2 would be our constant common difference. It's the same thing as a linear function. Will behave the same way. Yep. Okay. Okay, let's take a look at this sequence. Is this an arithmetic sequence?
I think so.
Because but it doesn't have a constant.
It's just plus 2 every time.
But it's not constant. So this is not arithmetic.
Oh, it has to be constant.
Yes. Now, there is a pattern here
It's plus 2, it's odds. But it goes up and down.
that it has a second constant common difference, which means that it's like a degree 2 polynomial instead of like a degree 1 polynomial.
But it's still not an arithmetic.
But it's not
That's the
arithmetic.
first one.
Yes. So you guys feel okay? Okay. The other type of important sequence is a geometric. And geometric sequences have a constant common ratio. We abbreviate that as R. So for example, this is a geometric sequence because I notice the pattern is each time I'm multiplying by 2. Everybody's okay?
So it's just a multiple compared to like a addition.
Or it, well, let's look at another example on what else it could look like.
Oh, this is it can be division or multiplication.
You don't want to think about it as division, though. You want to think about it as
Multiplying by a fraction.
times 1/2, multiplying by a fraction. Yes. So again, with a geometric sequence, if that's what you suspect it is, you want to always think about it as a multiplication problem. When we get to writing the formulas, you definitely want it written as a multiplication problem, not a division problem, because it's going to make your life harder. Always multiplication. So if it's you see division, you just know you're multiplying by a fraction, right? Yes, I would always want to think about it as adding a negative. 100%. Great questions. Everybody okay so far? So far, easy, medium, hard?
Easy.
Fairly easy, right? Okay. So I'm going to list the sequence here. I want you to identify whether it's arithmetic, geometric, or neither. Everybody's okay? Okay, how did you know? Okay, so right there we know it's not arithmetic, right? And here, going from 0 to 3, nothing you can multiply 0 by is going to get you 3, right? So neither is the correct answer. Does anybody see the pattern? There's a pattern.
Yeah.
It's adding by an odd number, like the next odd number, so it goes +3, +5, +7, +9.
It's the perfect squares minus 1.
This is like those connections from like New York Times that make no sense. Am I wrong?
So for example, 0 is 1 squared minus 1. 3 is 2 squared minus 1. 8 is 3 squared minus 1.
Oh, I see.
Yeah.
It's different ways to look.
How about this guy here?
It's multiplying by 3 each time.
That is correct, which means it's
Geometric.
geometric.
No, it's nothing. She said after I it would do like two weeks of that. I hope not.
How about this one? You don't like the fractions. What should you do to make this easier?
Make him a decimal.
No, man. Common denominator. If I look at these, what should the common denominator be? So 2 would be 12/6, 10/6, 9/6, 7/6, 6/6. Not adding.
Subtracting.
Yeah, we'll think about adding a negative. It is arithmetic. How do you guys feel on identifying sequences?
It's harder to do with fractions.
Yeah, that's why I gave you the fraction one, is to like give you the worst case scenario. But the trick is just make a common denominator. Or in the case of a multiplication problem, like if you wrote this as,
Oh,
Trying to help you out.
yeah, we ramped up a little bit.
Oh, wow.
That's what I'm saying.
it's a little easier to see because then this becomes like 3 to the -2, 3 to the -1, 3 to the 0, 3 to the first, 3 to the second. And it's easy to see you're multiplying by 3 each time. So it's just a question of like looking at the number in a convenient way. Okay.
Mr. Bullock,
Yes.
can I go turn something in and go to the?
I need
Yes.
to hold it for her.
Yeah, because I have to crunch.
I understand.
Thank you.
Well, let's do. Oops.
Is that like the imaginary eye?
No, that's just like an arbitrary I. Would you rather do K? We can write as K. K is not something else, right? Only in chemistry. Okay, so let's say we have the sequence 7, 9, 11, 13, 15, and we want to write the arithmetic or the explicit formula for this sequence. So you should observe what type of sequence do we have? Arithmetic. And should be easy to see that it's arithmetic because it's plus 2, and the D is equal to 2, right? And now if I look at this, I know that A1 is 7, A2 is 9, A3 is 11, A4 is 13, A5 is 15, etc., right? Everybody see that? I'm going to pick one of these to use. I'm just going to use that first one. Does it matter which one I use? Nope. So I'm going to write AN is equal to D times N minus I plus AI. Is everybody okay? And then if I want, I can simplify this down. And that's what I got. What does this formula remind you of, and what does this process remind you of? So this formula for the explicit formula for an arithmetic sequence should remind you of the point-slope equation for a line. Nope, that's the slope-intercept. Point-slope is y minus y1 equals m times x minus x1. That one. So this process is like writing the equation for a line given the slope and a point. The slope is the d. The point is some term in our sequence. Everybody's okay with that? We could make this a tad more challenging. Yep. So here I've told you it's an arithmetic sequence. And the two terms are that the fifth term is 10 and the 10th term is 25. Well, if writing the explicit formula for an arithmetic sequence is writing the equation for a line, then this is like two points, right? Okay, well, I can write the equation for a line given 2 points. I calculate the slope, which is just the same thing as d. I'll write it the other way. So 25 minus 10 over 10 minus 5. So there's my 3. And then I can use either one of these as my I and A sub I. And if I want, I can distribute things through, oops, that's supposed to be an N, not an X. Distribute things through and simplify. And I'm done. You guys okay there? Okay. We could also ask you to write a recursive formula for an arithmetic sequence. This is even easier though. So the formula for a recursive arithmetic sequence is a sub n equals a sub n minus 1 plus d, and we have to give the first term. So first thing I want to do is confirm this is an arithmetic sequence. Is it? The pattern is just plus 3, right? So there's my D. And then here's my first term, right? And I'm done. Pretty simple, right? What makes things a little bit more complicated is if I was given this same situation back here. So if I'm given this situation again, I'll find the D the same way. How am I going to find the first term? I'm going to write the explicit formula and use it to generate that first term. You could go backwards, but like, how simple is that, right? That's where it's at right there. And we're done. The downside is to find the first term basically means I have to find the explicit formula first and then write it. Feel okay? Okay, this is our stopping point. Your assignment is going to be a Delta Math titled Chapter C number 1. I think all of this chapter's assignments are going to be almost entirely Delta Maths. What did I want to do?
This is going to be a stupid question. sequences of what?
Series. You're welcome. So if you look at this delta math, there's just 4 types of problems. So finding common differences or ratios, it's going to tell you which one that you're doing to make it even easier for you. So here it says find the common difference. For this guy, what's the common difference? 8. Done. Cool with that? Okay. Here they've expressed it as a polynomial, the terms of our sequence. Oh no, no big deal though. Notice that the constant part is staying the same, so we just must be adding. My x's go from negative x to 3x to 7x. We are adding 4x, right? Boom, done. Writing the nth term of an arithmetic sequence. So they give you the sequence and then they ask for the 88th term. What are you going to do? Write the explicit formula and then plug 88 in. Everybody's okay? And then same idea, but here they're given you as polynomials. Everybody's okay? That's it. That's today.
I'm supposed to leave at 2:50.
Oh, see you later.
Have a good day.
You too.